Today's lesson is on section 6.5, solve absolute value equations. We've dealt with absolute value in the past. One thing to remember about absolute value, what does it look like in a problem, is these two long lines here around a number or around an expression. And usually after talking with students or asking them if they remember anything about absolute value, they can usually recall that, well, absolute value of -6 ends up being just +6. The absolute value of +8 is also just +8. And if you have some kind of expression inside the absolute value is kind of like a special parentheses, where I would like to find a number first. We need to find some kind of number for that problem. Like if there's an expression, I have to do everything in there, find that answer, and then take the absolute value of it. So 2 minus 4 gives me -2, and then I can take the absolute value in -2, which is just +2. So as we notice from absolute value, what happens is we always end up with the positive of whatever we're looking for. The definition I'm going to put up right now, it's kind of blocked there at the end, but if you're taking notes along with me, you can write down the definition. And again, usually after asking, students can come up with this, but the absolute value, what does it mean? It's the distance a number is away from 0, and we're talking about on the number line. So like a number like, let's say, -7, it has a distance of 1, 2, 3, 4, 5, 6, 7 spots away from 0. So that's why the absolute value of -7, if we had like a little problem, the absolute value of -7 is 7. Same thing with +7. So it starts over here, 1, 2, 3, 4, 5, 6, 7. It also has an absolute value of 7. So because it's 7 spots away from 0. So again, that's kind of one of the reasons why we always end up getting the positive when we take the absolute value of a number. We don't really talk about a negative distance. We don't talk about like traveling -20 miles today. Usually we talk about just traveling 20 miles. So same thing with numbers on the number line. We talk about how far they are from 0 in terms of a positive distance. So going back to the first page, we can talk about evaluating an expression that has absolute value in it. We can also solve absolute value equations, which is what this section title is. So that's what we're going to concentrate on a little more. A problem like this says solve, and it says take the absolute value of x. Your answer has to be equal to 2. So whatever numbers I put in for x here, whatever numbers go in there, they have to be numbers that when I take the absolute value of them, I get 2. Often with absolute value problems, there can be more than one answer. In fact, in this case, there's 2 different answers that could work in there. I could put 2 in for the absolute value, and that would give me 2. Or I could put -2 in. The absolute value of -2 is also 2. So I would say for this problem, I'd just say x equals 2 or -2. Those are my possible answers. And sometimes in an absolute value equation, if they're kind of simple ones like that, where there's not a lot of operations going on, that's all it takes for solving them. This one also, absolute value of x equals 6. So x has 2 possible answers. X could be 6. The absolute value of that would be +6. Or it could also be -6. If I put -6 in here, absolute value of -6 is also 6. So again, 2 possible answers. That's kind of how we can see that there are two possible choices that could fit in for that equation. Okay, I think I've got a few examples here. Next one, very similar. Absolute value of x equals 11. So again, you can just put x. Well, x could be 11, or it could be -11, kind of like we've been explaining recently. Number 3, though, here I have something different up. This problem says take the absolute value of x, and you got to get -19. This is a different problem. It's saying take the absolute value of something. And remember what happens seemingly when we take the absolute value all the time? Going back to our first problems, we always get the positive. In all these problems, we get the positive after we take the absolute value of something, correct? So this problem, going back to the one we're talking about now, says take the absolute value of some number and you got to get -19. As we'll find, we're going to run into some cases like this. This problem is impossible. There's no way I can take the absolute value of something and get -19. If this was +19, I could do it, but not -19. So this case, we'd say there's no solution or no solutions here. You could put plural or not, but there's no solutions to that case. This last one I got on this page, again, 1 and 2, we just had problems where like the answers are always some number and its opposite, okay? But they will get more complex. Now I have some expression in here, x plus 2. There's a little more to do in a problem like this. So there's going to be a couple answers again, but it's not going to just be some number and its opposite. Most of the time when I talk about this problem, students, I can even ask them what are the answers of this problem going to be, and they can usually tell me, well, x is going to be 5, that's going to be a possible answer. If I put 5 in there, 5 plus 2 would be 7, absolute value would be 7 as well. But then thinking of the other answer is a little trickier, because it's not negative 5. Thinking it out, if I look there, well, I mean, what could I plug in for x here that I could add 2, and it would give me an absolute value number that would give me 7 still? Well, after a little bit of thinking, you can figure out actually that negative 9 is going to be the number to work. Negative 9 plus 2 will be negative 7. And then if I have to take the absolute value, I should have the lines around all the time here. But if I have to take the absolute value of negative 7, that will give me 7. So the answers to this one are negative 9 and positive 5. Okay. Well, there's a nice way to get these without just kind of thinking it out like that every time. Kind of like we showed here, kind of like we've talked about for absolute value. If I'm going to take the absolute value, just kind of emphasizing, of some expression and get 7, well, there are 2 possibilities then, right? This expression inside of here, this expression, x plus 2, okay? I have to be able to take the absolute value of whatever that number ends up being, and it's got to be 7. Well, as I talk about, and I'll keep explaining here in future problems, then there's only 2 ways that can work. Either this x plus 2, either this expression, I have to find a way for it to equal 7, or the other possibility is this x plus 2 could also equal negative 7. Because like we talked about before, what ways can I have something in here in the absolute value that would equal 7? Well, there's 2 possible numbers, 7 or negative 7. So then what I do is I set that expression and say, well, that's that expression then, x plus 2. It's got to either end up equaling 7 or negative 7. So those are my 2 cases. They'll get me to my 2 solutions, as I'll show you right now. I can just solve each one of these just like a little equation. So I'd subtract 2 from both sides in this one. I get x equals 5, which is one of the answers we found. Or, my other solution, if I subtract 2 from this one, x equals, well, cancel this out, negative 7 minus 2 gives me negative 9, which again is the 2 solutions we kind of figured out by thinking it out earlier. But if you just break it into these 2 cases, okay, you don't have to do a bunch of thinking or figuring out. It's a lot easier if I just break it into these 2 and solve these little 2 linear equations and find my 2 answers. So if you're taking notes along with me, and again, you like something concrete, you know, what exactly am I supposed to do on these problems? Here's a nice line that might help you. When solving absolute value equations, many times there's 2 different answers. And so we need to solve the equation for those 2 different cases so that I can get one answer and get my other answer. Same thing here with number 5. So I'm going to show that right now. Number 5, breaking it apart just like I did the last one. It says take the absolute value of 2x minus 3. So if I'm going to take the absolute value of that and get 10, well then there's 2 things that this expression could be equal to, where it'll be a number that I can take the absolute value of and get 10. There's 2 possible cases. That expression, 2x minus 3, whatever that ends up being, if it's equal to 10, that would work, because the absolute value of 10 is 10. Or, if 2x minus 3, when I figure that little expression out, if that ends up equaling negative 10, the absolute value of negative 10 is also 10. So here are my 2 cases again. Often again, you'll see me draw arrows. I'll break it into those 2 possibilities. These are the 2 ways it could work, that I could have something for x that would get me to an absolute value of something that would get me 10. That could either be 10 or negative 10 inside that expression. Now again, I'm just going to solve them like 2 little equations, and they'll end up having almost the exact same steps because they look similar. I'm going to add 3 to both sides. 2x equals 13. Divide both sides by 2. X equals 6.5. That's one of my solutions. Or add 3 to both sides. 2x equals negative 7. Divide both sides by 2. X equals negative 3.5. Negative. Okay. There are my 2 answers. How do I know my 2 answers did work, or they are solutions? Well, I could plug them back in and see that they work in this original expression. As long as they do, well, then they must be all right. So I'm going to take 6.5 and plug it back in here. 2 times 6.5 gives me 13. 13 minus 3 would give me 10, and the absolute value of 10 is 10. So 6.5 does work. That must be one of the solutions. I can do the same thing with Negative 3.5. Take negative 3.5. Plug that in for x. Negative 3.5 times 2 would give me negative 7. Then I have that minus 3. Negative 7 minus 3 gives me negative 10. Absolute value of negative 10 is positive 10. So just kind of showing you that, yeah, both answers do check out. This method does work. Break it into the two cases. Once I have the absolute value by itself on one side, I can break it into the two cases and solve each one separately. That'll give me my two answers. I'll show one more example like this, and then I want to talk about one other new thing that can happen with absolute value, but I'll do this one kind of quickly just to give you one more example to see. So again, absolute value of 9 minus 5x has got to equal 16. Well then, 9 minus 5x could equal 16, or 9 minus 5x could equal negative 16. Either of those two cases, that would give me the absolute value of what I would need to take the absolute value of that number and get 16. So it'd have to be one of these two situations. That expression inside of here, 9 minus 5x, would have to equal either 16 or negative 16 for this to work. Subtract 9 from both sides. I'll do this one first. Negative 5 equals, let's see, I end up getting 7 there. Negative 5x equals 7. Divide both sides by negative 5. I get negative 7/5. Okay, so that's one of the answers. And that can happen sometimes. I might get a fraction or something. That's not a problem. Negative 9. Or sorry, subtract 9 from both sides in this one as well. Negative 5x equals, well, negative 25. Divide both sides by negative 5. I get x equals positive 5. So there are my two possible answers for this one. Again, I can plug them in too and see that it should work out. If I plug in positive 5 into this problem, I should get 9 minus 25, which would be negative 16. And yep, the absolute value is negative 16 is 16, so that one's good. If I plug in negative 7/5, 5 times negative 7/5 gives me negative 7. So in here I'd have 9 minus negative 7. Chop, chop. I'd have to add those. That would give me 16. Absolute value of 16 is also 16. Yep. So again, both answers check out. I'm going to show us one last example of something else that can happen too in these types of problems when you're solving absolute value equations. Or one more thing at least that you need to be aware of. There can also be problems that have an absolute value in it. Okay. But maybe the absolute value isn't by itself yet. If this is the case, then I cannot break it into my two cases, kind of like we've been doing for some of these other problems. Okay. So one more important note that I want you to write down here in your notes and realize is that we can only break the problem into those two cases once we have the absolute value by itself on one side. Because what we're saying is the absolute value of that stuff, that expression, is going to give me either, it's got to be positive 16 or negative 16 like we had in the last one. So that's the time you can break it into two cases. But we can't do it yet here. The nice thing about absolute value, though, is we can get it by itself on one side, just like you solve for a variable by itself on one side. Like let's say I had x minus 5 equals 10, and I said solve this equation, get x by itself. Well, what would you do? You'd add 5 to both sides, and I get x equals 15. So I can do something like that. I can do the same thing here. Treat that absolute value almost like this is your x. Treat this like it's your variable. So if I'm trying to get that variable by itself, or in this case, the absolute value by itself, I can do similar things. I can add 5 to both sides, get rid of these 5s, and then I can say, well, now I have absolute value t plus 9 equals 15. And then I can break into my two cases and solve. Just show another example like that, or go into the next page here. I'm not going to finish that problem because it's the same as we've been doing. But here's another one where the absolute value is not by itself. Well, again, if you want to look at this problem, you could treat it like this. There's the absolute value, but think of that like your variable. If you had to solve this problem, this little two-step equation, what would you do? I'd subtract 8 from both sides. I'd get negative 2x is equal to negative 4. I'm kind of running out of room here. I'm running into my recording. And then I divide both sides by negative 2. I'd get x is equal to positive 2. So I can isolate a variable. I can do the same thing here with an absolute value. So in this one as well, to start getting the absolute value by itself, I'm going to subtract 8 from both sides. That'll get rid of these 8s. What's left on the left side of my problem? Absolute negative 2 times the absolute value of x plus 3. and then that'll equal -4. And then again, just like when we get a variable by itself, I can divide this whole thing by -2, and this side by -2. That will cancel out these -2's over here. Now I just have x plus 3 in the absolute value equals +2. And now that I've got the absolute value by itself on one side, now I can break into my two cases. X plus 3 equals 2, or x plus 3 equals -2. If I do it at any step before that, it won't necessarily work out and give me the correct answers. But once I have the absolute value all by itself on this side of the equation, now I can break it into the two cases and find my two answers. If I subtract 3 from both sides, I'll get x equals -1 on this one. Or if I subtract 3 on the other side, I'll get x equals -5. And there are my two solutions. So again, when solving an absolute value equation, I can break it into those two cases to find my different answers. But just make sure, as I noted up here, make sure that you have the absolute value by itself on one side. And then you can go ahead and find your two solutions.